Ma'am, shall we start now?
Yeah, sure. Questions are held there. After 10 seconds again.
Ariyam Tat. Very good morning to one and all. I, Shashankian, Assistant Professor in the Department of Computer Science and Engineering, welcome you all for this live streaming of webinar on TensorFlow 2.0. It's our fortunate to have Ms. Meghna Natraj, software engineer in the Google as the resource person. On behalf of Department of Computer Science and Engineering, Vidyavardhaka College of Engineering, Mysuru, I extend a warm welcome to you, ma'am. Welcome you, ma'am.
Thank you, Shashank, for the introduction.
And it gives me very immense pleasure to introduce our resource person of this live webinar, Ms. Meghna Natraj. She has completed her Bachelor of Engineering in Computer Science from MS Ramaya Institute of Technology. And she has also completed her MS in Computer Science from Georgia Institute of Technology. And she has work experiences in various reputed software giant industries such as Akamai Technologies from February 2014 to July 2015. And she also worked in Georgia Institute of Technology as a teaching and research assistant from August 15th to May 2017, and NVIDIA as data science intern from May 2016 to August 2016. And currently she is working in Bloomberg as a software engineer in machine learning and analytics, New York, from June 2017 to present. And she has also headed so many projects, to name a few of them: K-sparse auto encoders in the deep learning, scene recognition with convolution networks for visual recognition, movie recommendation system in the machine learning, and Passage, a travel safety assistant, which make use of data and visual analytics. And she has she has some notable achievements, such as she has worked as a HR lead, sourcing and recruiting 100 plus volunteers that at Make a Difference, which is a non-profit for shelter homes in India in 2015. And she is also the winner of Hackathon of Georgia Tech Convergence Innovation Completion. Thank you so much, ma'am, for having you as a resource person. I request you to take over the session. Over to you, ma'am.
Thank you so much, Shashank, for that wonderful introduction. And I'm really glad to have this opportunity to talk about TensorFlow and machine learning. And I know that a lot of you are quite passionate to pursue this. And I'm glad to share my journey from doing my master's in computer science and machine learning through my work experience as a machine learning engineer and my current job at Google. So, okay. Just some assumptions that I'm going to make is a lot of you are already familiar with deep learning and TensorFlow. If not, just deep learning is basically using neural networks or basically a kind of model around how our brain works or neurons work, which do certain mathematical computation, take some inputs, give an output, and all of that builds into a complex structure and can be used to do complex tasks like image recognition or speech recognition and so on. And we can do this using deep learning frameworks such as TensorFlow or PyTorch and so on. So that's about a gist of what this will be based on. And I would like to keep it interactive. So I am assuming if you guys have a mode of asking questions, feel free to. So a little about myself. Shashank's already given an introduction, but I work as a software engineer at Google. There's machine learning engineer, research engineer, research scientist, like a lot of names, but pretty much everybody here is a software engineer. So yeah, I guess that's what I've been doing for the past 1 year at Google. And I work specifically in the TensorFlow lite team, which is focused on machine learning for on devices, on edge devices. So like mobile devices, like your phones, it could be a laptop, your earbuds, and it could also be microcontrollers that could involve your washing machines or refrigerator and so on. So sort of pushing machine learning to these devices as well. Previously, I worked as a machine learning engineer at Bloomberg for 2 years, and I also did my master's of science in machine learning in Georgia Tech as well. So the agenda is that I'm going to cover, there are a lot of sort of tutorials out there for TensorFlow 2. So you could obviously start off with TensorFlow 2 on the website itself, so the guides and tutorials, but it can be quite overwhelming for somebody who's starting off. Another thing is there's a huge contrast between what TensorFlow 1 is and what TensorFlow 2 does. So it's sort of switching over from that mindset can be quite difficult. So I'll just do a tutorial walkthrough for a couple of minutes. Then I'm going to talk about TensorFlow Lite, sort of my domain and what I'm working on, and to just expose you all to what are the new things that people are working on. And then I'll discuss machine learning interviewing. I think this is quite crucial and not much discussed is understanding what's the job market and how you interview and what my process was, and Q&A if that's possible. Okay, so TensorFlow 2.0, I actually am just going to open I think it'll be much better if it's quite interactive and if I can walk through a tutorial to show you. So there is a link, so you would have access to this video, and there are a lot of resources out there, but this is a TensorFlow user group user created a link of I guess tutorials and TensorFlow 2 guide that you can use. And over here, there are a couple of crash courses, which are all Jupyter notebooks that I would highly suggest that you try. Another thing is just using the TensorFlow 2 guide and tutorial to get started, but this can be quite overwhelming and quite a lot to take in. So the best thing to do is to just code and just see exactly how you can get started. So I am basically going to focus on the TensorFlow 2.0 plus Keras software crash course and just cover some very key concepts or very key things that you need to know to get started. Okay, so this specifically uses, let me see if I can increase the font size here. Then that would make it easier. Yeah. Okay, so just so right now, the open source version is TensorFlow 2.3, which has a couple of features, but which is not required. So I'm just going to stick to TensorFlow 2.0 and to introduce you to sort of new features that exist. If you've already used TensorFlow 1.x, then maybe you can relate to some other content that I'm going to talk about. So this is a Jupyter notebook. It's basically like a cloud interactive notebook where you can run Python commands. And you can sort of simply open Colab. You can just search for Colab, and it should ideally take you to a UI. Sorry. I opened my internal link at Google, so that wouldn't work. So if you just search for Google Colab and you can sort of just, if you just Google it, you should be able to find a link to it, and you can just start a new notebook and immediately start coding. And this will have access to TensorFlow. So you can directly import TensorFlow. You can connect to GPUs as well. So if you want, you can connect to a GPU and TPU, and it's all for free for about 12 hours. So it's pretty good if you're starting off, you want free GPUs and things like that. So what I've done is I've already opened an existing notebook, the link that I just opened, and I've installed TensorFlow 2.0.0, like a specific version already. Okay. and you can sort of use this to verify that you've actually installed it. Okay, so Francois is basically the sort of creator of Keras and TensorFlow, who created this tutorial as well. So I'm sort of using his creator's guide to kind of go over this. So in TensorFlow 1.x, it was sort of something that was built internally at Google. So it wasn't built for usability. It was just built because it was fast and it could be used for production. It was used internally. So it was very difficult for users to use it. Like programmers found the concepts very difficult. So if you had to create, let's say, a variable A and B, and if you had to add them, then you would have to create a graph. Define a graph, and then you have to create a session and actually add them inside that session for it to be computed. So it's a very confusing concept, and you're like, okay, if it's just A and B, why can't I just do A plus B like I do in like normal Python? But it was extremely powerful because it's extremely quick and fast to use because of this graph-based method, and you could use it for production. On top of that, there was a library called Keras that makes it quite easy to use. So if TensorFlow was quite difficult, Keras was built so that you could write simpler code. In TensorFlow 2.0, the whole thing was redesigned so that it's much easier for users to use it. At any point, you guys start using TensorFlow 2, and if you have any issues, you can actually just go for GitHub issue. If you just type GitHub issue TensorFlow, and you will be able to quickly file an issue, and that's actually taken quite seriously internally, and we actually look through and try to resolve as many user issues that you have. Okay, so yeah, it's a machine learning platform from the future. If any of you have used NumPy, it's a popular machine learning library. It helps you to manipulate data quite easily. And similar to how you use NumPy, you can basically use, you can run code in a very similar way in TensorFlow 2, and I'll show that to you pretty soon. And it also helps, basically a lot of these clunky, difficult to use APIs were simplified. So some basics that you need to understand is everything, all the variables. Like for example, if you were to define A equal to 5, A equal to something, that is just like, let's say, a constant. Then you can have a 2D variable and a 3D matrix, and then you could have an ND matrix. So in general, all of these are called tensors. And so it's TensorFlow. And how you can define a tensor, tensors can be a constant tensor or it can be a variable tensor. So when I say a constant tensor, it's something, let's say, like a value that you want to add, and its value is fixed. Let's say you want to add a value of 0, or you're performing an operation like a ReLU, and you want to use max of 0 and something. So 0 is a constant, so you define it as a constant, and that helps TensorFlow to do some optimizations, because if something is a constant, then you can store it differently, and so on and so forth. So that's why we define constants and variables separately, because it provides some optimization. So you would define a constant by saying tf.constant, and you would define like a normal matrix like you would do in Python usually, but you would just define it as a constant. And you can also define a tensor full of ones and zeros, and you can just sort of print that, and you will see that it's a tensor. Now, how you can access its value, or let's say you want to access its type and shape and so on, you can do that by just printing it, just like how you access a NumPy array, like x.dtype and x.shape. And if you were to get its value and actually print it, you would just do .numpy and you would get a NumPy array. So you're working with it like you're working with a NumPy array. Again, I'm assuming familiarity with using NumPy arrays. If not, you can just sort of think about it as a normal Python variable, but with some additional properties where you can do large data set operations like slicing and adding and filtering and things like that. Okay, but in TensorFlow 1, if I had to sort of just define, so instead of doing x.numpy, I would have to define a session, and then I would have to run this variable through that session, and only then it would print a certain value. Further, if you want to do math operations, it's a lot easier in the sense that you just do a plus b, and you would do something like dot square of something, or multiply, or do exponent and do any math operation. And it's pretty much a part of the TF library. So you do TF dot a lot of math operations that can come with it. And again, if you had to do this in TensorFlow 1, you would again have to define a session. You would have to define all of these functions and then run it through, and then only get the value, which is not easy for a new user to work with. Now, let's say you want to build a model, right? And then if you want to train some variables in it, so you want to train it, then you would have to define weights and biases. And all of these are trainable values. So for that, you would have to use a variable because over time they get modified. And for that, you would basically do the same thing. You would define a constant, technically, and you would define it as a variable on top. So then you're telling that this is going to be something that I'm going to be modifying. Again, if all of this is, again, just to reiterate, all of this can be quite overwhelming in the sense that it can be, I might be telling you a lot of things, but it's okay if you don't understand. It's sort of just so you hear all of these words and you're kind of familiar with it, so that someday it'll be useful. But if you're not following through, just try to get a gist of it. Okay, so back to the tutorial. So once you define a variable, if you want to modify it, unlike previously, you could sort of just assign the value to it. But if you want to modify variables, you would have to use specific functions like assign add, or assign subtract. These APIs are how you modify variables, and that's sort of how it's defined. So I'm going to skip over. So this is so until now, what I've covered is how you define just variables in this language in TensorFlow, which can further be now used when you create a model. So now Keras is something that helps you to build these different layers, helps you to define your metrics, your model type, and so on, and actually do deep learning. So the reason why some things can be still difficult to use, some things are easy, is that some people are, let's say, engineers who don't want to understand too many functionalities, so they just want a high level. They would just stick to using easy TensorFlow simple APIs. Whereas at the same time, some users who want complete flexibility of defining their own layers, their own customization, their own metrics can also do that. But I won't be covering a lot of in-depth usage. I'm going to try to cover just the overall simple definition of how you would build a model. So the one very main sort of a library is the layer class, and pretty much everything in Keras is derived from that. So, and there are many layers that you have, like convolution layer, a pooling layer, or with respect to like RNNs and LSTMs, a convolution, a dropout. All of these are different layers, and what you basically want to do is, when you're defining a model, you want to have an input, you want to define your own set of layers, and you want to define an output, and basically you use this library to do it. So how you do that is, let's say there are two ways in which you can do it. A little complicated way, in a very function object-oriented way, would be that you define, let's say, okay, this is my input, tf.keras.input. And then you can also define the type of input, the size and shape, and so on. Once you do that, let's say we're defining a very simple neural network, which is basically a linear, or this is like a fully connected layer. And you define that this is going to be the input of this layer. So it's sort of like a functional way, or an object-oriented way, where you're calling this as a function. Similarly, you say that this is now going to be the input to the next dropout layer, and then there's going to be another fully connected or linear layer. And then finally, you're going to say that my final model model's input is this, and its output is this. This is sort of a very, I personally don't use this, but some people like using this functional way, so I just wanted to show how you can do that. A method that I prefer is simply this. So you just do TensorFlow.keras, and you import a sequential. So sequential set of layers are just a linear set of layers, and you would define, okay, I have a linear layer, dropout, a linear and that's it. That's my model, and I just pass this input through it, and then I get an output. That's it. So this is pretty much how simple you can how simple defining a model in TensorFlow 2 is, versus having to define sessions and graphs and so on. So now let's talk about other things. So if you want to actually train a model, the next step would be to define, let's say, a loss class, which will basically tell you what makes a prediction right. So like, let's say you run all of this input through a model and you get some output. You want to find a metric that will tell you whether how far away this output is from my input. So when you have, let's say, outputs which are categories like yes, no, or just like the colors of something, or like whether it's a cat or a dog, you would use these metrics like binary cross entropy, categorical cross entropy, and so on. And you could use mean square error and so on for numeric related or regression problems. So it's pretty easy. It's all, again, a part of the tf.keras library. So again, we've entered sort of the keras domain here. So tf.keras.layers, tf.keras.losses will help you define losses. And then you also have metrics. And then as and when you're training your model, you want to be evaluating it. So we've defined the model. We've defined what makes an output good or bad. And now, as we're training it, we also want a metric to see whether it's performing well. And for that, you will use tf.keras.metrics. Okay, let me just keep that here. Okay. Then the next thing would be to discuss sort of an entire end-to-end loop on how you would do this. I'm actually going to go to a simpler training example. Yeah, so that's about it. So ultimately, if you were to train a model, let's look at sort of an end-to-end example. The final sort of end-to-end example would look like you could use existing data sets as well from Keras. So it's tf.keras.datasets. And you have a couple of data sets. I think there is some iris, and there's a common iris data set or an MNIST data set. You can load that. You can easily perform some pre-processing on it. So you're reshaping it here, you're converting the type, and then you're also scaling it from -1 to 1. So this is all the pre-processing that you usually do so that your model trains better. Then you actually define, so when you do tf.dataset from tensor slices, it basically prepares it for training or as a tensor input to the model. You can read through it in further detail. And then you can sort of shuffle the data because you don't want it to be, if the data set is in certain order, you don't want it to be sort of biased. You can define, you can ignore the buffer size, but you define a batch size of how many samples you want to run through the model each time. This could be a little kind of complicated to figure out, but once you start using it, it's fairly easy. But all you need to understand is you can define your data set, you can define the pre-processing. And then you define your simple model. That can just be sort of a sequential model. Dense layer is a fully connected layer, and you define the number of neurons, the activations. It's pretty simple. All your model is just this much. Then you define your loss, your metric, and your optimizer in just pretty much few lines. Then you bring this all together. So you bring your model, your loss, your accuracy, and your optimizer together in your compile step. And then you can just fit your data set. And that's about it. So pretty much in just these steps, you would be done defining a model. And honestly, this would work for an n number of use cases. So if you're starting off, you can literally pick a very simple model and then just sort of work with how that works. And that's sort of a summary, very short summary of what TensorFlow 2.0 can do. And there are many other tutorials. And given the time frame, I would actually cover something more useful, like probably there are good tutorials on like LSTM and RNNs and so on. But that's more for advanced usage. Yeah. that's about it. If you want to start off with simple things, which is what I did, all you're doing is just model.fit. But you can, people who are researchers, so this is what machine learning engineers would do, probably just pick a simple model and just do model.fit. But people who want to get into more research, and understand how the model is training at every step. At every point during the training step, you can add callbacks to see how it's performing, and printing metrics. If you want to define your own layers and try out your own algorithms, you have many other functions that can help you do that too. So it starts from engineering to research, sort of provides an entire set of flexibility to do that. Okay, that's about the gist of what TensorFlow 2 brings in. And if it's a little overwhelming or pretty easy, I was trying to just address it to a larger audience. The next thing that I wanted to cover is TensorFlow Lite, sort of an interesting domain, sort of introducing you all to what TensorFlow Lite is. So TensorFlow Lite is basically a machine learning framework. So just like it's just simply just TensorFlow, but it's optimized, and I'll explain that in a bit. So it's basically used for machine learning for edge devices. So it's mobile devices, embedded devices, like phones and so on. So to give you a more picturesque view, so if you were doing machine learning that is running on the cloud, that is running on your desktop, these are pretty powerful. You have GPUs, even a normal CPU on your laptop or your desktop is pretty good. But if you're talking about phones and even like microcontrollers that run on your small devices around you, you would have to sort of, you can't just take a big model that's trained on these machines, because they're pretty big, they take a lot of time to run, and so you need to do some sort of optimizations, and that's why TensorFlow Lite exists. And why TensorFlow Lite? Simply because when they built this library called TensorFlow, it was very big. It had a lot of features for training and so on, and it wasn't meant for these small devices, and TensorFlow Lite sort of does that. You can just sort of think about TensorFlow Lite as, let's take this library or this, when you do pip install, it's just like a folder of files, and you just take a subset of it, and you add some more features, and it's just TensorFlow Lite. And the advantage is that you don't really have to learn anything new. Mostly, it's pretty much taking existing models that you've trained as a TensorFlow model, and you sort of just do some sort of an post-processing steps, and then it becomes a TensorFlow Lite model. Okay. And yeah, so I guess I'm just going to run through this quickly. It's designed for the edge. So these are sort of the devices. If you are, let's say, building a product, or you have like an idea that you want to build machine learning on for doing some sort of on like a microcontroller on a very small device, usually like smaller companies who start off building their own businesses think of using machine learning for products like these, then using TensorFlow Lite would be a better option, because you have concerns about like privacy. You can't send data from these devices. It doesn't have Wi-Fi, so these models completely run on device. They don't use Wi-Fi, use less power, and they're pretty quick and so on. It's already used by like the Google Assistant, like Photos and Cloud, and Google, like your prediction on your phone. All of these already use these models, which are TensorFlow Lite models. There's a lot of tutorials that exist if you want to get started. So if you just search for TensorFlow Lite tutorials, you'll get a couple. So a common thing would be like running like an object detection. And in fact, I tried this out quite recently. And it took me about half an hour to 40 minutes. And I was actually able to run through the tutorial, and I actually was able to run it. So it's pretty doable. Even I sort of picked an external tutorial to see how I can run through it myself, and it was pretty doable in about 40 minutes. There's like text-based, so BERT is sort of a very big advancement in natural language processing, and mobile BERT, which is like an optimized version, was converted to TF Lite. So you can literally see that you can ask questions, and it would look through the paragraph and answer. So I think that's pretty cool, and it's a good use case. And it completely runs on device, so you can switch on the Wi-Fi and it'll work. And you can go even on even smaller devices, like small microcontrollers, and you can detect whether you say yes or no. So you can basically be stuck on a wall listening for hours and hours without any external power, and it'll be able to detect this. So yeah, so it's just used to make these edge used to run machine learning models on these devices, like let's say without Wi-Fi and quickly. Then if you want models to run on these, then you would convert them to TensorFlow Lite models and then run it. How does it actually work? I won't go too much into this, but when you think about a TensorFlow model, it's basically just code where you have it's just a set of mathematical operations. So you have input, which is a bunch of numbers or matrices. You have your weights and biases, which are also matrices or tensors or with some values, and you just do multiplication or addition, and then you get an output. And based on how they are defined, there are like 4 kinds. And you can basically do certain kind of optimizations just by the way these things are. So the model input and output are tensors, they're dynamic, so you don't know what the user is going to enter, whereas the parameters and weights are constants because they're trained during training time, so you can sort of store them in a different format. Okay. So how that's actually done is that when you're training, you train it on your workstation, on your laptop or your desktop, and so on. And TensorFlow, and you use TensorFlow for doing it, right? You want to do backpropagation. You have a lot of these variable parameters. Basically, you do training on your desktop. Now, what you want to do is, once you're done training, you want to do predictions. That's the second step. And you want to be able to do that, let's say, on your workstation or your mobile device or on edge microcontrollers. For that, you need separate set of features. Like, or once you train your model, now you're not going to train it again. So a lot of these things like dropout and backpropagation, all of that code is not required. You can think of it that way. So, but it's not quite easy to just take your model and run it on these small devices because TensorFlow is a very big library. So what was done is that it was broken down and a chunk of it was taken out, a part of the code, which became TensorFlow Lite interpreter, and it runs on your phone and it can understand a model that's optimized. So what you're going to do is, once you complete training a model, because you can't directly sort of run it on these devices, you are going to go through a conversion process, which is going to optimize it. So it's going to take a TensorFlow model, and then it's going to pass it through a converter. It's going to optimize it, and then you can run it on the interpreter. If you sort of know that when you're training a model, you want it to run on these devices, then you can probably there'll be future improvements where you can directly convert it to different formats. But that's like an ongoing process. Unfortunately, you have to do this 2-step process for now. Yeah. And you can use, also TensorFlow Lite has a lot of features where you can sort of optimize it. Again, these can be a lot of words and a lot of information overload, but you can do a lot of techniques where you can basically convert a model to another format where the accuracy is the same, but it's a much smaller and a faster model. And a lot of cool techniques that people have worked on in research. And so like you pick a smaller model that's optimized, that can run faster on these mobile devices, which have GPUs and TPUs and DSPs, and so on and so forth. Yeah. And I won't get into these details for now. Similarly, TensorFlow Lite micro exists. So we went over TensorFlow in a tutorial, which is to run it on these cloud devices. Then there's TensorFlow Lite for mobile devices, and then TensorFlow Lite micro. So why do you need to know about these? Because TensorFlow, like microcontrollers, exist on billions of devices, and it's an extremely huge market. And it has no operating system, and it just has a few kilobytes of memory. But we've actually been able to run machine learning on this. But why would I use it, right? So let's say when you do OK Google or OK Alexa, then you want the device to wake up. But if your device is constantly running and listening to you, and it's going to make a call to the cloud, it's going to be using a lot of network power and it needs Wi-Fi and so on. So because this is a very small operation, it's binary, it's just yes or no, you would run all of this on device using an even more optimized form called like lite micro. So in this use case, when you just want yes and no before you're going to make a cloud invoke the cloud for a larger model, you would use this. So some example is there's a tutorial for Hello World for microcontrollers where given an input X, it tries to predict a sign of X. And there are some cool examples on different microcontrollers where you're actually drawing the sine wave or the color, LED colors are changing and so on. So you can sort of try that out if you're interested. A couple of cooler examples that I think is a speech. So you can say yes or no. This is sort of a very popular speech example that exists. Then there's a person detection tutorial where if you walk in front of the camera, it's just 250 kilobytes of a model and it can detect whether it's a person or not. Then there's a gesture detection model. So you can sort of have different emojis and it can detect that. And these run on Arduino or some other microcontrollers that we support. So it's pretty cool. It's sort of a newer last 1.5 years of research that's ongoing. And another very important thing that I wanted to cover is machine learning interviewing, and sort of a process that I went through when I graduated and sort of navigated this all on my own. And I kind of wanted to help a lot of you because you're all in college, and the whole goal of being in college is eventually to graduate and get a job or teach or whatever it is that you'll be doing. And for that, usually you do go through this interview process. And I feel like something that's not covered and you're sort of left in the blank. I guess my experience is that I did manage, I mean, why you should listen to me or not, I was able to secure two offers from Google and Uber. Some companies froze hiring, and that happens often. So I had to drop my on-site interviews, and I got some rejects as well. So do take my advice with a grain of salt, but I'll try my best to be as helpful as I can. And I had a couple of more interviews that were ongoing. And I guess I took some and I got some no offers and so on. So my end-to-end timeline about how I planned that was that I decided that I'm going to take 2 months and just completely give it my 100%. So it started from studying, applying, phone interviews, plus on-site interviews. And I almost spent about 6 hours a day, and weekends were 12 plus hours. And I also had a 9-to-5 job, which implied I had no life at all, absolutely, which implied I minimized social interaction and just locked myself up in a room and studied for 2 months. And I did this about a year ago. So it's probably the most intense interview prep that I ever did, and probably the only time I ever did it. For machine learning, I find that there's not a lot of good resources out there. So I hope this helps you. So there are 5 domains that I would divide your prep process that it should include. One being that as a machine learning engineer, I see a lot of people who are very against software engineering and hate the fact that you're going to be asked questions like stacks and queues and so on. Unfortunately, the harsh truth is that about 70% of your job is software engineering. So you have to be good at it. And just accept the fact that the current process requires you to know this, and try to enjoy it, because if you're going to fight it, it's going to be worthless. Because like I know a lot of my friends and I, when we have to do lead code prep or Geeks for Geeks, whatever is out there, it's very frustrating because these questions are a hit or a miss, and you tend to forget them, so you have to kind of by heart them sometimes. But unfortunately, that's the process. And if that is the process, then just do it right. So you are expected to be a good software engineer. Yeah, that's about it. The second step is software engineering design. So if you have any prior work experience, or if you're looking for a higher position like a senior software engineer and so on, you would be given software engineering design questions in rounds as well. The third is machine learning basics. So just machine learning in general, like knowing algorithms. It could be like random forest, linear regression, k-means, neural networks, or like convolution neural networks, RNNs, LSTMs. So it's just knowing a breadth of this knowledge comes under ML basics. ML design and experience. This is where if you've already worked and if you've done projects, it could be projects, it could be work experience. So my work experience in Bloomberg was what I used when I was interviewing for all these companies, even at Google. So what project I did and sort of explaining end to end in a large scale production system. So that is sort of ML design. And ML design also covers company specific preparation. So if you're interviewing for, let's say, Uber, then specifically you think about problems that that company would ask. I'll get to that in a bit. And then there's the last step is data science prep. So data science prep is being more analytical. It's more understanding in a large scale, when I've trained these models, if I'm getting results, how do I analyze those results? What's my next step? What you Because we do machine learning, we get very stuck to notebooks. So all we want to do is just improve that metric. We want to improve the accuracy. But what is the point of doing that? You want to understand the goal, like how is it going to benefit the product and the business, and how is it going to bring revenue? So you want to understand that. So data science gives you that mindset, and you need to have that as well. So these are like the 5 domains in which you need to prep and give sort of equal weightage to. So the first is software engineering. So in my 2 months, I think my first month was just software engineering prep heavy focused. So I was doing cracking the coding interview. I think I took a week off work, and then I just finished this book, and I did a couple of questions from elements of programming interviews and some lead code. But I had never done interview prep before in my life. I had no idea. It was sort of starting from scratch. And I had to figure this all out on my own, just Googling and figuring things out. So I had never done this book or even a single question from this before. So I just got that book and I just did this whole thing. There were like 180 questions. So I just sat down and did all of it. Some I wrote by hand, some I coded, some I would just look at it and just come up with a solution. So I just did all 3. I would code as well. I would write as well, and then I would also just look at it and be like, "It's fine, I can do it." So, but do all 3 of them, but do code as well. So I was trying to do like a chapter a day, and I think they're like 10 chapters. So it probably took 1 or 2 weeks overall to do it. Then it was elements of programming interview. This is the most difficult resource out there. I did not know that, and I was struggling, and I thought that I was like, how do people do it? And then I found out that it is a very, very tough book. So if you are scared of a topic, let's say I was scared of DP, which is dynamic programming, trees and graphs, and I was just scared of these questions. Like I was afraid that if somebody would ask me, I wouldn't answer it. So what I did was I just sat and I did like whatever 15, 20 questions that were there in this book, in these chapters. Very difficult. It took me almost 2 weeks to just do 3 chapters. But after that, like your confidence level just goes up like 50%. And I think I'm glad I just did those 3 chapters and I sort of skimmed through the rest. So pick what you're scared of from this book and do it, because it's really difficult. So it'll help you build that confidence. Again, these I coded a bit, did it by hand, and then sometimes I would just guess, sort of do the code in my mind and then just move on. Lead code was when I got the premium subscription. I thought it was, I think it's extremely worth it. If you have a couple of friends, you can all pool in and just get it as well and create multiple sessions. Has all levels. The best way to use this is before a company's interview. So if you're interviewing for a specific company, it's been super helpful for Amazon, for Palantir, for Google. No, actually not for Google, but like 2-3 companies. I just did the last week or last 3 months question. I actually got some questions, and I would say it's lucky as well. It worked out, so it was pretty useful. So yeah. And then another thing is I would always, if I'm waiting in line, if I'm waiting for my lunch, if I'm bored, if I'm standing somewhere and wasting time, I would just open Lead Code and do some easy questions or medium questions. So it's a nice way to kill time. Okay, second is software engineering design. So if you have any prior work experience, what I would suggest, and if you want to go for a higher position, I would say use the books, previous books, all the 3 books. I think all these resources have some design, system design questions on this thing. I did those as well. And a lot of good YouTube, like I don't know, users who create content like Mr. Charoy, Tech Dummy, Success in Tech. They have these really nice. They cover just broad domains. So all companies that do transportation, like Lyft, Uber, let's say Ola. If you want to be able to answer all the questions related to these companies, it's just how is this app built, and how would you answer it? So you would just if you would just look at a system design interview, if you look at all of these videos 3 or 4 times, there's a pattern in which you design. So you think about scale or fault handling, the database, and things like that. And I guess a couple of notes, a couple of things, pointers that you need to follow. That's about it. That's literally a template. I can't really recall much now, but if you just follow that template, you can pretty much answer any system design interview question. Yeah, that's about it. So just look at 5-6 videos. Just Google for system design website, like I guess resources, and just you can probably watch these 3-4 videos and you'll get a pattern, and then try actually doing one yourself in front of a mirror or with a friend. Because when you actually do it, you'll realize how difficult it is to actually talk about it for an hour. So just at least 2 or 3 of these, try doing it yourself. The ML basics. I had already done the machine learning by Andrew NG. I went through some notes from my Georgia Tech machine learning course. And then I did this book called An Introduction to Statistical Learning. This was good because it's a bridge between data science and machine learning research. So it explains concepts like A/B testing, p-value. I think I've forgotten quite a bit, but it basically talks about all these concepts that help you to answer machine learning questions in an interview. And all it's quite important. Like you want to be able to analyze your results and tell why you would make certain choices, and it covers a lot of that. And I would say these are relatively easy, and the difficult one is like pattern recognition. If you're going to more research roles, definitely that's a good book. I did that in grad school. Extremely difficult. And so if you want to go into research and interviewing for those roles, go for that book. And also deeplearning.ai has a free Coursera course for deep learning. It's fun to watch and revise concepts. So I watched a bunch of that as well. So based on what you're going for, if you're going for a more engineering role, the left 2 resources, going for a more research role, the right 2. But either ways, you can mix and match. Next is ML design. So if you were to interview for a particular company, or a day or 2 before, what I would do is sort of just shut down everything and just have that company in and out in my mind. So I would look at their blog. So let's say Uber has an engineering blog, and I went through everything machine learning related that they're doing, like their microservices, or they have a Michelangelo, which is their machine learning platform, and they have Ludwig, which is a deep learning toolbox, which is completely internally built, and all of these engineers create blogs. Google has a blog. Almost all companies have a blog. Open that, research, know things well as much as you can, and just understand what these are. You can always use them when you're talking to somebody as well, and they would be like, "Oh, this person did some research, and they actually care." So understand. The second thing is go through Glassdoor questions. Super useful. People generally tell you what kind of machine learning or software engineering questions have been asked in the past few months. Okay, then ask yourself, what is the product's core job? So like Uber, it would be, let's say, okay, so Uber would be, it's a driver rider company. So drivers are trying to find riders are trying to find drivers. You have to match them, you have to price it. You want to be able to give a certain price. So that would be a regression problem. So you can literally come up with 5 questions of what the company is about. And I was always asked these 5 questions. So I would always go prepped for that. LinkedIn was, how does the news feed work? Facebook was, how does the feed work? How would you recommend friends, or things like that? How would you have ads structured on the feed, or how would you even show a feed on Facebook? Google would be ads, or I could be search, like search recommendations. So you already know these machine learning algorithms. You know what the company is about. Just read those concepts well. most of the time I was usually asked the questions that I would think about, and usually they would ask that. Another thing with machine learning interviews is you are the driver for these interviews, so you can drive them to ask you those questions. That's the trick. So they would be sort of be like, okay, what do you know about? And I would obviously, talk about recommendation systems if I was interviewing for Google, and they would be like, how do you build an ad recommendation system? I was like, thank you, I came prepared. Or so you would have to drive them towards it, and they will ask you that question, because machine learning or deep learning is such a huge domain that, like, what question can you ask, right? So you are the driver for the interview, so you can make them ask questions that you want to if you're smart about it. It's not tricking them, it's sort of helping them as well. And another thing which I did not cover is all of these they would always ask me, what did you do before this? So have one or two very strong projects. So my work at Bloomberg was something I used. I didn't go into details because I couldn't disclose a lot, but I had already spent a lot of time having this like 15-20 minute prep that I had sort of learned how to explain and rehearse and spoke about it, that every interview almost 1 hour was just me explaining that. So like, let's say, like, what did you do at Bloomberg? And the moment I was there, I had practiced it so much that I would sort of just explain that, like, I did this, I scaled it, this is what happened, this is what did not work, in order to improve it, we did some sort of other recommendation stuff and whatever, just sort of the whole story that you have. And yeah, sort of have one good project that you can really go in depth and explain. Data science. So data science prep questions are where they come in, is because every time you go through a machine learning interview round, they're going to be like, okay, let's say this doesn't work, your results don't work, what will you do next? So let's say you'll be like, I did A/B testing, the results were so and so, and then you'll be like, this did not work. So now I would try like regularizing, or I don't know, using a different, I don't know, data set, different split. I can sort of go into that in a bit. But you'd have to sort of think about what kind of questions can the interviewer ask. Usually you can sort of think about you yourself as an interviewer and what you would ask. So it could be like classification versus regression is very lame as a question, but it could be what are generative versus discriminative models? What is AOC, AUC? What's the AUC? Different metrics, explain for categorical versus numerical, what sort of metrics would I use, what kind of different optimizers exist, and so on, like examples like that. So these sort of data science interview, I would just Google a lot of YouTube videos on data science interview questions. So whenever I'm bored, I will just look through them. So like 20 questions asking things like, they would basically ask you like different kind of questions that might require 1 or 2 line answers. And this is also very useful because people do tend to ask that. Okay, mock interviews, aka practice, of course. For a long time, I ended up just doing this by myself in front of a computer. And when I had to actually talk in an interview, my first few interviews went really badly because I did not give mock interviews. So mock interviews are basically when maybe like a website like Pram, which will sign you up with somebody, and you both will interview each other. It was extremely useful. You can also bother friends, but I would highly suggest go to a room, have an official interview for 20 minutes with friends or with anybody who's not you. It has to not be you. And take it very seriously, time it. It cannot be a fun joke thing where you sit and you chill. You have to do it seriously, and then that makes a very big difference. Like sort of doing it live with somebody else. It's very scary because you think you're going to be embarrassed and feel stupid, but it's super useful. Trust me, you have to do it. So, for example, in Pram, one person explained all the flaws and mistakes in how I was talking and so on. And he told me a strategy to follow, which I followed and worked brilliantly, which was every interview design question went like this. So they'd be like, okay, this is the problem, increase user interaction on a website. So I'd be like, okay, what's the metric that I'm tracking? I would discuss a couple of metrics, come down to one, which would be like amount of time spent per day. So it's a regression problem. So I would tell that, and then I'd be like, okay, the features are, I would look at like location, device, user demographic, like posts, likes, comments, shares. All of these are categorical and numerical. I would like label them, give examples. Then I would say my class or label would be the time spent per session or per day, and it's a regression problem. And then I would talk about how I would do feature analysis, like how I would handle missing values for all of these, how I would remove outliers, how I would plot and scale and do one-hot encoding for categorical values, so on. And a couple of more in introduction to statistical learning, they go very in depth about how you pick the right features. So it's a very good resource. Couple of tons of other points that I've just removed, but it's included there. Sorry, I'm running out of time, but I'm just going to take 5 more minutes. Then I would discuss what models would work for it. So for regression, I had some models. For classification, I had some models. I would just literally say the same thing every time. And then I would talk about testing. So I would tell that, okay, I tried this and this failed. I would actually give them an example of something that failed. And then I would tell them why this failed, like my own reasoning. I'd be like, okay, my demographic was incorrect, or I did not do this, blah, 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 and how I would work on it and improve it, or how I would try different things like regularization or whatever. Yeah. So I have this another module of why something would fail, and then I sort of would pick one of them and then say why it failed and actually solve the problem myself. And the interviewer just sits there watching you solve your own problem. So it's pretty fun. Then building a personal brand. This was something I feel like as engineers we've never been taught. It's sort of in an interview process, especially I remember in India when I got my first job, it was almost like, thank you for giving me a job, which is wrong because it's a two-way process. You're getting a job because you're working, and they're giving you a job because they need you, and it's sort of like a handshake versus thank you. And it's very hard because, yeah, like jobs are scarce and people are more, but sort of changing that mindset is quite important. So build a personal brand where you're sort of where you're talking as if you're not thankful, but you're sort of like, I'm also good at it, but without sounding overconfident. So I can give you an example. So like somebody's like, okay, you have a Google interview and they're like, why do you want to work here? Normally people will be like, Google is amazing, I love YouTube, search has changed the world, blah blah blah. Commonly heard. You've just wasted 2 minutes of your time with the interviewer or with the recruiter and added no extra value because they know this. Instead, you could be like, from my experience working at, like I worked at Bloomberg, or you could say from my projects at blah blah blah, at whatever school, like VVCE, I've enjoyed designing and leading and building scalable software that can impact and help users. And at Google, I'd have the opportunity to continue to do that at the largest scale possible. And I hope to get an opportunity to make an impact. And you can add some more personal comments about what you've experienced, like using the product. So in that way, you're selling yourself. At the same time, you're being a little humble. So sort of try to have that perspective. It really helps and leaves a remark. So sort of making them be like, oh, like this person is awesome, like a little different and stands off. Another thing is negotiating with recruiters. Sort of done. I don't ever remember doing it in India, but there is a culture of sort of negotiating your position and salary. At least your position, I'm sure, and salary can be to quite an extent negotiable. It is negotiable, and you should know that, and then you should try doing it, and that's okay. There's nothing wrong. It's not wrong doing it. And that was sort of a very hard concept for me to understand. And there's a lot of articles out there for that as well. Hard work is not equal to success. That's my last point and that's okay. I know people who interviewed without all of this prep that I did, and technically they did end up getting like a better position or better salary and so on. And I know people who put in a lot more effort, like 10 times more than what I did, and who it did not work out for. So it's going to be this whole spectrum because interviewing is a very confusing process. And especially with COVID, I'm sure it's a lot worse. And so that's okay. You just, it's just how it is. Just accept it and just give it your best. And don't have the imposter syndrome that you're not good enough and all that stuff. It's fine. Everybody feels that. Just slog and just work hard and then give it your best. And I hope all of you do really well. So at the end, my current work, everybody tends to think it's really fun and fancy, but it's just, especially with machine learning, like how it's actually math internally. A lot of my work is software engineering. And I've realized that I tend to like that a lot more than the machine learning work, because machine learning can keep you up at night because if something crashes, then you won't know why. And a lot of growth is associated with like your coding and how much engineering work you do. So I sort of prefer a job that's more engineering involved and a little bit of machine learning. Because with engineering, you write a test. If it works, it works. If it doesn't, it doesn't. And then you go to bed, you sleep peacefully. With machine learning, if something fails, it's very hard for me to explain why. So I've found that I don't enjoy that much. But yet it's really fun. I more enjoy sort of like um, working on tutorials or working in this domain, but on a more software engineering side. So my I guess advice is that find what you like. Again, my experience is limited. I've worked on these projects sort of solo. I've never worked in where like 4 or 5 people are working on the same research project. I've always worked on it alone. So maybe my experience is limited. But I guess my point is try to find what you like. Don't just do it because everybody's doing machine learning. There's like all this FOMO out there. ML is not going anywhere. Explore everything and then try to figure out what you like in this. So if it's research or engineering or machine learning engineering or whatever it is, and do that and just don't do something because others are doing it. That's about it. This is some guide and resources that I used here, and yeah, that's about it. Thank you.
Thank you so much, ma'am, for this beautiful session. And we have a short Q&A session now.
Yeah, sure.
Participants have asked a few questions. The first question is like this. A participant by name Abhishek Rao, working as assistant professor from NMAMIT, he is asking a question. He is not able to create an exe file using PyInstaller. It displays an error message saying import error, no module name underscore pywrap underscore TensorFlow underscore internal, fail to load native TensorFlow runtime.
Very difficult for me to debug that. If it is possible for him to sort of create a GitHub issue and share it with me, I can personally look into it. But I won't be able to answer that specifically right now until I debug it and like look through it myself. But I can definitely follow up and help the user out.
Okay. And he has asked one more question. He has installed Python 3.7 and TensorFlow 2.1.0 in Anaconda Navigator.
Okay.
And it works fine actually. But when he creates an exe file, it creates a problem. What can be the solution for this?
I'm not sure if I can sort of. There shouldn't be an issue with these two versions as such using Anaconda, but I haven't worked with creating exe files, so I'm not quite familiar with the workflow what the user is trying to do. But if I can have sort of a link to sort of Stack Overflow question or GitHub issue, I can look into it.
Okay. Ma'am, one more question from Cynthia Devi, ma'am. While training, you have given reshape with some numbers. Can you tell me how the pre-processing is done here?
Okay. Let me look at it. So I can tell you about like why the reshape would be done. A lot of time when the data set comes in, let me just share that. Can quickly share it and open. Oh no, I closed the tab. Let me just open that in a second. Yes, I'm trying to find. Oh yeah, found it. Okay, there you go. Okay, so I guess it was about reshaping, right? Yeah. So usually when you get a data set input, the shape might be not well defined. So it could be like 60,000. Okay, so the shape of this training data has 784 columns and it has 60,000 rows already. But the shape might not be 60,000, 784. It could be 60,000, 784, 1 or something. So it's sort of not a well-defined, clean structure. So to be honest, we can probably try. Probably it's not needed. Sometimes I've seen that when people do this, it's sort of not needed already. Oh, okay. Oh, yes. Okay. This is an image. I completely forgot that this is a nest. So because it's an image data set and you have a 28 by 28 image, you are basically converting it into a flat vector. So that entire vector would now be the input to your model. So that's why I guess it's reshaped. So this gets reshaped into a flat tensor. But sometimes what happens is the shape can be sort of this. So it can be, sometimes data sets tend to have this weird shape, and that is why we tend to use this. So 784 comma 1 or 1. I'm not sure if that's possible, but sometimes data sets tend to be of this weird shape. So that's why we tend to run this reshape command. So one is for that. Second is because this is an image data set and you want to flatten that vector out. Once that's flattened, you do as type float 32, because sometimes there is no type defined for this, and your model basically needs a certain type for your data sets. Sometimes it's just better to define the actual type so that it doesn't make assumptions like float 64 or int 16 or whatever it is. So you usually define float, because in the next step you're dividing it by 255. So if your data type was an integer, which it is, right, because it's an image, so it'll have values from 0 to 255. So if you just do this, if you do divide by 255, all the values become 0. Whereas if you make it a float, then when you do divide by 255, it'll actually do a floating point operation. So in that way, it'll range from 0 to 1, and you're normalizing it basically over here. I would not go into this, but this is basically prepping the data set for training. And you're sort of defining that it's going to be of type data set. When you do this, it helps you to do these operations where you can shuffle, you can create batches. Normally, if you have to do this, it's very painful. You would actually have to you have to run a for loop, you have to define 64, 64, and so on. So because it's so painful to do that, you define it as a tf.dataset, and like from tensor slices, which you can like read into. I wish they named this better, but they haven't. But somehow this is just used to do these cooler operations a bit later, so then they can be used in the model directly. Yeah, that's about it. Yeah.
Ma'am, one more question is there from Sushma S. She's asking, will you please tell us more about microcontrollers? Give me something, which books to refer and something
For sure,
like
for
that.
sure. I actually worked in that team when I joined. So, so if you just Google TF Lite Micro, so I'm just Googling TF Lite Micro as it is, you will get an get started link. There is also like a video with examples, but there's basically a GitHub page, and then there's a website. So if you go to the website, it basically talks about, sorry, I hope I'm sharing. Sorry, I'm so sorry. I'm not sharing my screen. Sorry, guys. Okay. Yeah, so I guess you can see that screen. Okay, so all I did was I Googled for TF Lite Micro. It'll lead you to the website, which will basically talk about what are the supported microcontrollers that we currently support. There can be other microcontrollers as well, but it might be a little difficult to run it on them. These are the best ones. So if you were to, there are a bunch of examples. So that already exist. So what you would do is, let's say you would pick one example, let's say hello world. Okay, I would go to hello world example, and then it's going to basically show an example of like how what you're trying to do. So it's like, given an input x, you're going to predict sign of x, which is a regression problem. There is a folder for training specifically that if you open, it will basically tell you how to train. So there's a collab notebook, like let's say you can open that, and you can actually learn how to train this model. So you're actually training this model, and then this is like the basic tutorial, so it's very well explained. Then you're going to convert that model to a TensorFlow Lite model. Then you're going to convert that model into a TensorFlow Lite micro model, and then it's going to basically output like this C binary like file. This file will now be deployed onto your microcontroller. Just copy paste it, you can think of it as. And once you do that, and like if you, let's say, follow through some steps for running it, which is given in this page, for different microcontrollers, there are different steps, then you would be able to see a demo like this. So I would just say sort of go ahead and explore. There's also a TF Lite Micro book, which was written by the lead or the tech lead, or sort of my mentor or at Google, and it's called TinyML, machine learning with microcontrollers, lite on Arduino and microcontrollers. This is sort of how I'm trying to get you a picture of this. This book. So then, yeah, this is sort of how it looks. This is the book. I think you would have to buy it. What I would ideally say is that everything that's there is already available on the website or on the GitHub link. So if you go to the GitHub link, and if you go to like the whatever the microcontrollers GitHub, if you just type TF-Lite micro and go to the first GitHub link that you find, and if you go through, I'm trying to find the examples. Yeah, so if you go through some examples, there are a bunch of examples. If this is very confusing, you can just stick to the website view, which basically have like these 4 examples. This is what's there in the book. So you can buy the book if you're interested, or you can just directly use these 4 links. So it has a hello world, speech recognition, a person detection, and like a magic wand, sort of an example that you can run through. Again, these are all quite experimental, so it might be a little difficult to run it. But yeah, it's available for you to try out. If you face any issues, you can also file like a GitHub issue. Yeah, that's about it.
We have one more question.
Yeah.
From Professor Jamuna. Ma'am, how long do you think the TensorFlow framework can last?
Just 1 second. Could you repeat the last part? Oh yeah, I got that.
Yes, ma'am. How long do you think the TensorFlow framework can last? Of course, on a note that technologies keep changing.
Yeah, it's quite difficult. This is also a conversation that we have internally. It's like, this might not even exist in 2 years if we change the way everything works, because there are so many. There are almost 8, 9, 10. All of them are very good, popular deep learning frameworks. So I guess, I mean, there is like a competition and things like that, and no one quite knows. But I do know that the big ones, where there is a huge community or an engineering base, that could be like TensorFlow, Cafe, and then PyTorch, and some other ones. As I guess, as long as users are actively developing it and using it, it would work. But I can say that there's a lot of engineers internally at Google, and like really good ones, really smart folks working on it constantly, trying to think about what users want, or how this whole industry is headed, and that is why like TensorFlow Lite or Micro did not exist, and that came in to be because no one like thought about it, but like there was a need for it, so it changed. So again, TensorFlow can drastically change is how it functions, but yeah, only time will tell. Shashank is buffering, so I can't quite see.
Okay. Can you able to hear, ma'am?
Yeah, I think.
Ma'am. Pratyush is asking the question. Ma'am, please elaborate about the job opportunities in machine learning for freshers. He's in 3rd year working on machine learning, but
Yeah.
few people tell that there is no good jobs for the freshers in machine learning. Can you please
Yeah.
elaborate on this?
First thing I would say is don't listen to anybody. Second thing is, it's kind of true. It is. I went through that process. It was extremely difficult, because when you're in school, what you're studying is not going to apply in the real world, and everybody's looking for machine learning experience. With software engineering, they don't expect experience. With machine learning, you're expected to have worked, but that is okay. All you have to do is apply to a ton of places, try to get referrals at places where your friends or people already like know are doing machine learning. Try to get experience through projects at school or at work. Another thing I would say is, try to get a job that is close to machine learning, but it may not be in the best company. So let's say if that's what you want to do long term. So I know a lot of friends who wanted the high paying jobs, which are usually software engineering jobs in bigger companies, where you won't get machine learning jobs or like positions. On the other hand, there were people who went to startups, did not pay well, but they did like proper research in machine learning and deep learning, and they still are doing that. So it's about also choosing that. But to be honest, the real, like, you have to also think about what do you want to do in your job. Your job is not going to be at all like what your school was. School is really fun, right? You just open this nice data set, you run this whatever like tutorial that I ran, and then you get these results, and then you keep doing this for again and again. And every time you do submit a new assignment, it's like an image recognition model, speech recognition, and an RNN or LSTM or like transfer learning on something. And it's just fun. All of that is fun. But when it comes to real industry work, when there's business involved and there's product involved, it's going to be 85% like non-machine learning work, software engineering work, which is irritating and annoying and boring most of the times. Just to be honest and just to be realistic. And this is what every machine learning engineer or research scientist, anybody who's not teaching and writing papers and doing research. So anybody doing research, either let's say as professors or in the industry as research scientists who are constantly writing papers, if you're not doing that, then 80% of your job is going to be boring software engineering. So that's another thing you need to know. That is machine learning, that a lot of it is engineering, software engineering work, and maybe 20% is machine learning. So yeah, so I guess by that definition, yeah, it's not going to be 100%.
One more question is there from Sonu Kumar. What are the jobs for data science in the current scenario in this world?
Is it with respect to COVID or just generally? I know that, yeah, it's quite difficult because a lot of I do know people who are working at these startups or who are doing ML work and things like that. I'm going to be honest. Again, I'm not going to sugarcoat anything. The first jobs that do get laid off are research, and things like, you know, like in these companies, it's like because they're not providing value, or it could be like they're not generating revenue, and things like, you know, like ads or whatever. Software engineering work that's constantly generating revenue tends to be a little higher up the ladder, and so hiring would have reduced because of that. But again, all I would say is don't think so short term. Eventually, it's going to be fine, very long term, right? Like someday, if you see, look at a history of, we've had many COVIDs or whatever come and go in like human lifetime. So it's going to go away, but I don't know, maybe a couple of years it'll be affected. And if you can find something that has software engineering and machine learning, or you can do something on the side, but try to do that. So like, I guess reprioritize. That's what I would say.
The last question, ma'am, from Professor Jamuna once again. Could you please talk a bit research challenges in machine learning?
I think the research challenges are, I mean, I was sort of in the bridge of it, but for me personally, I came from a very software engineering background. I guess the research aspect, oh yeah, the one thing is sort of constantly being updated with all the machine learning research that's going on. So it's very hard to know the breadth of knowledge and to know depth. So I know some people who are deep in research for machine learning using whatever, like transformers only, for NLP only, and so on, and they spend day and night doing that, then you can be good. If you try to learn a lot, it's really hard, it's really overwhelming. So I think research in general is very overwhelming. There's like a lot of people publishing a lot. And again, there's this demand, like I see that internally as well, that researchers need to publish, need to bring out results. So it's kind of, I see a lot. And second thing is they're working 24/7. Like honestly, they're just working all the time. And I tend to find that being difficult as well. So I guess staying updated, second is that. And I guess just making these decisions, right? Like why something fails and what to do next and things like that. So in research, being in the right environment is quite important. I mean, I've always worked solo on projects. I think that's why it's been quite hard for me. So maybe someday I'll work in a where a group of people are working on the same research project, and then I might have a better perspective on what are the real challenges people face. Oh, I can't
actually. Okay. A small request actually from Professor Abhishek Rao. He has asked that he wants to share the code, whatever he has written, and he requesting you to share your email ID.
Okay. Yeah, I can share it with you personally.
Okay, ma'am, thank you.
And then
So that we can share that
Then
with
you can
the
email me.
participants.
Yeah. Oh yeah. Thank you.
Now the question and answer session is over, ma'am. Now, on behalf of the Department of Computer Science and Engineering, I extend a heartfelt thank for your valuable time for sharing a very good insight knowledge on TensorFlow 2.0, TensorFlow Lite, as well as how to become a successful ML engineer, what are the challenges and what are the employment opportunities and how to get prepared for that. Everything you explained in detail. Once again, thanks a lot for this session, ma'am. And also, I also thank all the participants who joined us across the globe for this very useful, informative session. Stay home, stay safe, keep your health in a better condition. Have a happy learning. Thank you all. Thank you so much.
Thank you so much.
Thanks a lot, ma'am. Thank you.
That's great. Thank you.